set the switches here, and then it gets data when I want it to get data. I actually have to put this in the roof of one of our buildings. The LSU press building, old press building. So what this does is that it gets data, air quality data on a predetermined time from what time to what time. I just set it here. So what happens is, in this case, I have exposed filters. So I place the filter inside. So this is maybe on a quite clean day. Quite clean. Why? Because initially when the filter is put in, when this is put in that cartridge, what you see is that it's colored white. So the edges. And then after 24 hours, this is what I get. What I do is, of course, before I place this here, I know how much this weighs, how many grams. And then after I've exposed it, to know how much this weighs, I bring it to Ateneo. They have the microbalance there, to Jenny. So then after I've taken it, after Jenny's made the pre-exposure measurements, I take it from her. Once I need it, I put it in the cartridge and then I expose. And then this is relatively clean. Maybe it rained during the data acquisition, so that the air was relatively clean. Compare that with this one. Not clean. Okay? Compare it with this one. Okay? Air quality will change. The amount of pollution will change. Of course, depending on parameters that are occurring in the environment. If it rains, it's relatively cleaner compared to when it's not raining. Okay, so there's going to be a problem if it's not going to rain tonight. Because the air will be very dirty. So here you can see, so the air quality changes. And then what I do is, after I've exposed it, I go back to it, bring it to Jenny. And what Jenny will do is, she will again get the weight of these things. So she will tell me, oh, now this one, previously it weighed just 1 gram. Now it weighs 10 grams. After exposure, it weighs 10 grams, suppose. But it's impossible for this to weigh 10 grams. Okay, then I can know how many grams was deposited. How much dirt or pollution was deposited. Okay, gets, which is 10 minus 1, 9 grams. 9 grams of dirt was deposited here. And then I know how long I exposed it. 24 hours. Okay? Then I can know how much air went through this one in 24 hours. Okay? I can know how much air was deposited in 24 hours. Then I can get the what? The concentration of pollution in the air for that 24-hour period. Okay? But that's for that 24-hour period. And then I only learned about it after I have brought it back from Ateneo. So I only know that the air was dirty on that day, days later. After I have taken in that air and let my lungs do the processing. Okay? So this is an example of a passive measurement. Government has this. Okay? So, of course, this is not as good as when you have a real-time measurement. Okay, real-time means whenever I want to get data, I turn it on, and then the programs, the computer programs, process the data immediately. And then right now, after I've taken the data, I can tell you it was this dirty. Okay, so maybe much better. However, if you want it much better, of course, this is not as expensive as that thing. As the laser. This will not cost you more than $1 million. Okay, that's more than $1 million. So it now I think is 2 million. That big thing is 2 million. So this one is our laser. 10 years ago it was just $1 million. So now it's 2 million pesos worth. So the question was, it's going to get dirty. And then is physics doing or engineering doing something about it? Yes. Of course, we can do measurements. We can design more exotic instruments to do more precise measurements, real-time, accurate. And then, of course, we can also clean it. But of course, it will be more expensive. Our country has other problems. So if the country buys it, more people maybe will go hungry. So maybe it's not yet feasible. So also another thing is, even if we do cleaning, even if we do monitoring, as long as the people are not conscious about the pollution that they generate. Okay, for example, if you still use your car, even if it's run down or a smoke vector already, then it will not change anything. I would just die of doing so many measurements. Diba? So in the end, everybody has to do something. In your own small way, you can help, actually, even if you're not a physics major. How? Make sure your car is properly maintained. Carpooling, mass transport, diba? And then of course, you inform other people. Hey, your car is a smoke vector, why don't you fix it? Use my car. Use my car. No. Or telecommute. Diba? Work from home. Diba? That's the in thing. Maybe in some places already. You can do your work from home, and then with the internet now, it's getting faster, cheaper. So it's better to work from home, and then of course, what they say is, if you go to the restaurant, you still use your car, why not try to walk and then time your shopping to be what? So that all your errands are in one direction. You don't get to use your vehicle too much. That saves you time, money, and then of course, the air. Something that we don't usually mind, why? Because it's there. We don't see that it's dirty. Diba? We don't, unless we go outside of Manila, that's the time that we see that the air of Manila is dirty. But if we are in Manila, we don't get to feel it's dirty. Okay? We just breathe, and then we just trust that our nurse will be the one to do the cleaning for us. And then the lungs will be the depository account for that. We just pay later. Okay, we get sick, and then ultimately we die because of too much pollution. So, yun. Everyone has to do their share. It's not enough for just us to do measurements or buy equipment, clean it. Of course, there are techniques to clean it. So the pollution is the things that we create, the dirt that we produce that goes into the air. So exhaust of the vehicles, the factories, if we burn our trash, okay, dust, we create. Whenever we tear down buildings, we create dust. Diba? Of course, there's also natural sources. Okay? It's blown away if it's not held by the ground so tight. Okay? If the soil is loose, it will be blown away by the wind. It will form part of pollution. But that's natural. It's okay. God created it. Diba? But man-made is the one that's bad. Okay? That one we have to solve. And not only government, but probably some people usually they what? Government should do this, government should do that. First, they should think about how they should do that problem, how they should solve that problem. It's basically us. We should be conscious of what we do. On the roof, we have a sun photometer. What does the sun photometer do? It tracks the sun. It's a sun photometer. So it measures the amount of sunlight. So it will only work during the day. At night, there's no sun. So it only works from sunrise to sunset. And then what that does is, it again gets data about the atmosphere. But does it again remotely? Of course, we are not in the sky to do a measurement of the atmospheric parameter, the pollution there. We are here. So the sun photometer tracks the sun, points to the sun always, and then gets the amount of sunlight reaching the sun photometer. If there were a cloud blocking the sun photometer and the sun, then that's registered as a dip in the signal. Okay? If there is no cloud, like what you see now, between the sun photometer and the sun, then there's no dip in the signal. There will just be small variation in the signal because of the pollution present in the air. So the small dips that you see here